This is LEGO's model of the International Space Station. It's impressively detailed because it was designed in collaboration with the actual space agencies that support it. But I was a little disappointed when I realized that I couldn't fully appreciate the little details in the model because I wasn't personally familiar with the actual station itself. So I decided to fix that. The ISS is a beautiful testament to human cooperation. It's composed of a multitude of modules from NASA, the CSA, the ESA, JAXA, and Roscosmos put together over the course of a decade. The main structure is composed of a series of ITS modules. ITS stands for Integrated Truss System. Aside from ITS Z1, the very first to be deployed, none of them are habitable. They're purely structural. You'll find a number of panels along the main structure. Since the station is almost continuously bathed in harsh, unfiltered sunlight, it uses solar arrays to power itself. The white panels, however, have the opposite role. They're radiators. On Earth, objects cool themselves by losing heat to another medium, like air. But in space, there's no such medium to cool the station, which becomes a problem when every machine, every experiment, and every crew member generates heat. It wouldn't take long for the station to overheat itself and cook its crew dead. The white panels get rid of this excess heat by radiating it into space as infrared light. There's a number of extruding structures along the spine of the ISS known as ELCs, Express Logistics Carriers. Here, Express stands for Expedite the Processing of Experiments to the Space Station. Yeah, they really wanted it to say Express. These 4 ELCs provide mounting surfaces and electrical power for science experiments, and more importantly, ORUs, Orbital Replacement Units. Basically, spare parts like pumps, batteries, antennae, and the likes. You'll also notice this little number right over here. This is the AMS, the Alpha Magnetic Spectrometer, a particle physics experiment by CERN that detects antimatter particles in cosmic rays. Now we get to something that's a little close to me, and that I'm sure you'll recognize a part of. It's the Mobile Servicing System, a contribution from
the Government of Canada.
First, you've got Dexter, a remote-controlled robot that can be sent anywhere on the station to make repairs without requiring a spacewalk. But the one thing that I really love, and that I'm sure you'll recognize, is the Canadarm2.
Oh, Canada!
Canadarm2 moves around on a rail running the length of the station's main truss. It's used to move Dexter around, as well as install new modules and move existing ones to new locations on the ISS. It's also used to help dock spacecraft. Canadarm2 is basically a bigger, more advanced copy of the one aboard the shuttle. The main purpose of the ISS is to serve as a space laboratory. So, where are the labs? They are 3. The American lab is Destiny. The European lab is Columbus. And the Japanese lab is KIBO. KIBO is a little different because it's made of 2 main sections, one pressurized and the other one exposed to space. In the exposed facility, the experiments are left, well, exposed to the vacuum. It also even has its own little manipulator arm. These labs are connected to nodes. The nodes are where the astronauts eat, sleep, exercise, live basically. There are 3 of them. Node 1 is called Unity, Node 2 is Harmony, and Node 3 is Tranquility. Node 1 is where crewed craft dock. Specifically, they dock to connectors known as PMAs, pressurized mating adapters. Node 3 is where you'll find the famous cupola, built by the ESA. While you might know it for providing gorgeous views of our world, its primary purpose is to monitor robotic operations as well as EVAs, extravehicular activities, spacewalks. Node 3 is also connected with the permanent multi-purpose module called Leonardo. It's basically a storage area for supplies, spares, and waste. On the other side of Node 3 is Beam, the Bigelow Expandable Activity Module. This module is very unique. It's a balloon. Well, technically it's known as a expandable habitat. It takes a lot less space to transport, which will be a crucial advantage in manned missions to other planets. Beam is the first field test of this sort of technology. Across from Node 3, you'll find the joint airlock, known as Quest. This is where the astronauts store and maintain their spacesuits, and it's where they exit for spacewalks. Finally, we get to the Russian section. It's composed of two main sections, Zarya, the functional cargo block, and Zvezda, the service module. In the ISS's early days, these were the primary sections of the station. Zarya provided power, communications, and altitude control, though now it mainly provides storage and propulsion. Similarly, Zvezda used to house the living quarters, life support systems, electrical power distribution, data processing systems, flight control system, and propulsion systems of the station. Some of these functions have now been shared with the nodes. Two Russian modules that aren't included on the model for some reason are Pirs and Poisk. They serve as docking ports for the Russian segment, as well as EVA support for the Russian Orlan spacesuits. Pirs is located on the nadir, or bottom side of the station, and Poisk is at the zenith, or top. That covers the station itself, but the ISS could not operate without support from so many different spacecraft, so I'd hate to go without mentioning them. One of the most famous spacecraft of all time, second to maybe only the Saturn V, is the Space Shuttle. The Space Shuttle was instrumental in building the ISS, carrying most of the modules to orbit. The Soyuz capsule is probably the longest enduring spacecraft out there. At the moment, being the only crewed capsule in use, it is definitely vital to the ISS program. That being said, there are still a number of non-manned craft in use. But just recently, on May 30th, we got to see the first crewed launch of an American spacecraft since the shuttle was discontinued with SpaceX's Dragon 2. But it wasn't just that. The Demo 2 mission, as it is called, was the first human spaceflight on private spacecraft. We're inching ever closer to becoming an interplanetary civilization, and I couldn't be more excited. Cheers to the future. That was just cranberry juice, by the way. Not wine.